the cosine of theta equals 1 over square root of 2, right? So now you say, oh, well, I can just rationalize the denominator here. So therefore, the cosine of theta equals a square root of 2 over 2. And you say, oh, when is this equal to that? When is cosine of theta equal to a square root of 2 over 2? You say, well, that's going to be equal here and here, because that is square root of 2 over 2, comma, square root of 2 over 2. And then here is square root of 2 over 2, comma, negative square root of 2 over 2. Now we just got to know what those angles are. Well, this angle is pi over 4. And then this one's going to be pi over 4 all the way around. So that's going to be 8 pi over 4. So then that would be 7 pi over 4, right? So then you say, well, what are all the solutions? Those are solutions on the unit circle, right? Well, there's no real like easy relationship between these two. So what you can basically do is you can basically just add 2 pi to them, because add 2 pi is going to take you all the way around the circle back to the same solution. So what I would say is theta equals a pi over 4 plus a 2 pi n. And n represents any number. So you can go in the positive direction or in the negative direction. And then my other solution is theta equals a 7 pi over 4 plus 2 pi n. All right, the next one is kind of the exact same thing, but just remember that tangent of theta equals a y over x. Now it's negative. Now that's important for something to be negative, because when your y over x is negative, that means it has to be an angle in the second or in the third quadrant, right? Because everything's positive in the first quadrant and everything's negative in the third quadrant. So it has to be in these two quadrants. Now we got to see, well, which y coordinate over x coordinate is going to produce that? So here's the cool thing. Actually, let me do it here. Okay, so we're looking in this quadrant or this quadrant. There's only 2 other angles that we are aware of that are going to give us this value, right? We have square root of 3 over 2, comma 1/2. Then we have this angle right here, which is 1/2, comma square root of 3 over 2. So you look at this and say, well, which one of these, when I take my y coordinate over my x coordinate, is going to give me a square root of 3 over 3? Forget about the negative for a second. Well, it looks like it's going to be this one. And let's just double check my work. So if I had a 1/2 divided by a square root of 3 over 2, right? Well, the 2's are going to divide out, right? You can just multiply by 2 on the top and bottom. So then I get 1 over square root of 3, rationalize the denominator, and I get a square root of 3 over 3. However, that is positive, right? So my angle, remember, has to be in this quadrant and this quadrant. So therefore, my angle is going to be here and here. Now, the cool thing I want you to recognize here is that these two angles are half the circle around from each other, right? So all I need to do is figure out what this one angle is, and then I can just add pi to it. I don't need to add 2 pi, because if I add pi, it's going to take me here. If I add pi, it's going to take me back here. So you can keep on adding or subtracting pi infinitely many times to get that solution. So now I just need to figure out, well, what is this angle? Well, what is this angle? This angle is pi over 6. This angle, then, this has the same what we call reference angle here of that, which is also pi over 6. So it's pi over 6 away from pi. So if I broke this up into 6 equal parts, this would be a 5 pi over 6. So my answer here is theta equals a 5 pi over 6 plus a pi n. And again, I just need to, if I add pi, it takes me to here. If I add pi again, it takes me there.